Hey guys, welcome back. For this week's video, I'm just gonna dive right in because there's a lot that I have to say on this topic and this subject. It's also one video that I wasn't going to make for a while, but then I decided everything that I'm going to share and going to talk about and kind of put out there ties back to this concept and what this video is going to talk about. So I just needed to do it. And the reason I was wanting to put it off is because it's kind of, I don't want to use the word controversial. I don't think that's the right word, but it's just kind of the big idea behind mathematics education and elementary mathematics education right now that has people talking. And that is the two words, strategies or algorithms. Strategies or traditional algorithm. And kind of going to talk about what those mean, what those look like in math classrooms, how they play out, and just a general discussion about those things. Okay, so for the sake of this video, when I'm talking about algorithm, most of the time I'm going to actually be meaning the traditional algorithm. And when I'm talking about traditional algorithm, I mean the way to add and subtract mostly, but also multiply and divide numbers in that algorithmic way most of us were taught, where you add ones first always. If you have any left over, you regroup, or if you're subtracting, you might regroup or borrow or trade. When you're multiplying, you put down this extra zero. I'm out of practice from all of these things, so I don't even remember all of the terms because I don't use those in my own math experience, but those are what I'm talking about, that traditional algorithm. The reason I want to say that is because when you say algorithm, that actually can mean a lot of different things. In our American school system, there is our traditional algorithm, but in other countries, they actually use other ways. Other ways are their traditional algorithms. They don't even think of adding and subtracting in the way that we do. And you've probably seen a lot of that on the news or social media or through your children's classrooms, these things of like, so-and-so in this country, they do it like this, or they do it like that. So there's these different algorithms, but for the sake of this, I'm talking about mostly the traditional algorithm, but also the algorithm is a way that we teach students that they can copy because it always works and it's quote unquote faster. So the big goal is we want students to be able to get to those answers faster, so we teach them this way that always works. And there's many ways, there's more than one way that always works, so there's actually a lot of different algorithms, but the algorithm is a way we teach and kids like copy it. They learn that rule, they learn the song, they learn the poem, that algorithm. Versus this idea that has come into play of teaching or helping kids create strategies. And there's kind of a little bit of this back and forth discussion about that. Okay, so what I want to talk about is, like I was saying, an algorithm can really be anything that students just learn from you and then they take and they use it. So a strategy that we have put out there can also just become an algorithm. And I think a lot of people's frustration with math and elementary math is that we started realizing that students don't need to be calculators, that we have calculators and we have computers, and we really need students to be problem solvers. So that was a good realization. That is something very true. But then we have these math curriculums that came out and said, okay, let's teach them all these different ways, all these different strategies, and then make them practice them all. And what eventually happened that made people frustrated, rightfully so, a lot, is that the kids were getting overwhelmed because now they had all these algorithms to learn. They had to learn to do it this way, and then learn to do it this way, and then learn to do it this way. And it really just became, the algorithm grew to 8 different algorithms, and students already struggled. They already struggled to learn the traditional algorithm for addition and subtraction and all these. So what really was needing to happen was not to introduce kids more things for them to learn from you, but to help kids create these strategies based on their true deep sense of number. And I am not saying also that you shouldn't introduce them to all these strategies, because that could just be helpful to show them like, hey, this kid did it this way this one time, or look how your friend did it over here, and then they might go, oh, that made sense to me. But if it doesn't make sense to them, what they might not need to do is take home a whole packet and do it that way again and again and again and again, because now we're just back to this algorithm that we're using. So to me, when I'm using that word algorithm, I'm talking about making students do it in this certain way. And that could be partial sums, that could be even open number line. Making them do it in that way then becomes their algorithm. just something that they're doing because you did it, and they're gonna do it the way you did it, and now we made ourselves feel good because it's a different way, but the kids are still really not getting in tune with that number and that number sense. So okay, the next logical question is then, how do we build this environment where kids are building strategies? And to that, I would go back to probably beating a dead horse and say we need to help them really come to know number. And if students know number really, really well, and then they know value of number really, really well, and they can unitize, which we'll go on to it in just a minute, then they will begin to build some of these strategies. So one, they need to know number. They need to be doing things in younger grades like manipulating numbers with manipulatives, subitizing, looking at dot cards and knowing quantity, being able to break quantities into smaller parts and realize that those parts make this bigger number, this whole, and they can make these other parts, just manipulating, just like they do with sounds when they're learning to read, manipulating with numbers a lot. When they get up into older grades where they're going to start learning to add and subtract, a big, big emphasis that will help your kids is to emphasize value. And I'm using just the word value on purpose because we have units and usually just a few lessons on place value, but most of those lessons are really just focusing on the place part. So they want the kids to write down what's in the hundreds place, the tens place, and the ones place. What they're not really emphasizing is the value part. What is the value of the thing in the tens place or the ones place or the hundreds place, and how that can look different. So the number 134 has a 1 in the hundreds place, a 3 in the tens place, a 4 in the ones place. But students can know that just by looking at the number 1, 3, 4 and parroting that off again and again and again. But 134 has the 1 is a 100, the 3 is 3 tens, a 30, and the 4 is 4 ones, a 4. It also has 13 tens and 4 ones. It also has 12 tens and 14 ones. It also has 10 tens and 34 ones. It has all of this value with all of these different ways. And that's where we want students to get to know numbers that well. I always say, and it sounds maybe kind of weird, but we want them to know numbers intimately. That they're flexible with them, that they are thinking and talking about them in all of these ways where you know they have that number line going in their head and they're manipulating with the numbers. So when students know value of numbers, that numbers have these parts that can be broken up in different ways, then when you show them that these parts can be put together with other parts to make these new parts, they're starting to add. They're thinking additively. So they can put 50 and 50 to make their 100. They can put 100 and 100 to make their 200, things like that. And that's where these strategies start to come in. One of the strategies we see a lot that is really intrinsic to students is partial sums. And the reason that's intrinsic to students is because it really focuses on value. It doesn't just focus on digit, where the students are really not thinking bigger than 9. Because think about it, if they're adding traditionally, they're really never adding a number bigger than 9. They're making their tens into a 1, and you're hoping they're thinking of that as a 10, but how do you know? So when they're using a partial sums, they're actually using their value of their numbers. And that is really how a lot of people, at least in my experience, do mental math. And let's pause here and think about that for just a minute. Because there are 3 ways really to do computation and calculation in our modern age. There is paper pencil to solve, mental, do it in your head, or calculator. And again, I know I've said this, but I'll say it again. Most of us are going to use the calculator, especially for larger, more important numbers. We really want to get it right and we want to be quicker. We're going to use the calculator. And then after that, really most of us use some kind of mental math. We really don't most of the time pull out pencil and paper. So again, we don't want students to have to rely on that, but if they have this really deep understanding of value, then they're going to start putting those values together and doing that more intrinsically. When students do that more intrinsically, then they're building their strategies. And it doesn't always look the same because a strategy doesn't have to always be your strategy, and it doesn't always have to look the same certain way and become an algorithm. So the algorithm was created by people who needed a way to do math quickly because they didn't have calculators and their job was in a field where they needed numbers quickly, and somebody discovered that this way always works. That's what we want your students to get to. They want to discover, oh, when I do it like this way always works, and I can apply it to these other ways. That is a student-discovered strategy. Now, we realize that the students are not going to discover all of these many strategies that are out there on their own, and they're not really supposed to. What's supposed to happen is they understand a strategy that works for them. Does it hurt for them to practice other strategies or see other strategies? Probably not. Does it hurt them if they have to master all the strategies? Possibly. Because that might overwhelm them and put them off toward math, and then put parents off toward math because parents are overwhelmed too. Understandably, it is overwhelming to have to learn 7 different ways to do math, when really we could pare back, look at the bigger picture of what do we want students to get out of math class. We want them to be problem solvers that understand number and can manipulate number on their own. Okay, so that can work for addition, subtraction, even multiplication. In my 3rd grade class, we're doing like 2-digit by 1-digit multiplication, and I've put some videos on my Instagram if you'd like to go see how my students have intrinsically started thinking about this, because we've been working on multiplicative thinking for so long. They know when they have 4 26s that they actually have 4 20s and 4 6s. And that's how they think about it. They can even do it, most of them, in their head. They can do their 4 20s, 80, their 4 6s, 24, 104. And they can explain that to me. And I didn't have to teach them this one faster way, because actually the way that they got to it is a lot of times faster. So I hope that clears up a little bit of this conversation around strategies and algorithms and what those are. So when I say something like I don't really use the traditional algorithm in my classroom, that's really what I'm talking about. So you'll know that for future series. And I hope that you can find some ways in your classroom to get your students to know numbers really, really well. And a way you can do that is, of course, through number sense activities, games, and warm-ups. And if you need more information on number sense warm-ups, you can use in a 1st, 2nd, 3rd, even 4th grade classroom. They're really, really versatile. You can look on my blog. You can go to aubreyteaches.com. And remember, math is natural. Happy teaching.